Hello there and welcome to A2 Maths on Specimen Paper 2, and here we're looking at question 4, a modulus graphs question. So part A is sketch the graph with the equation of y equals modulus 2x minus 5, stating the coordinates of any points where the graph cuts or meets the coordinate axes. So what I would probably draw first to get myself a rough idea of what the shape will be is just your bog standard 2x minus 5 graph without any moduluses in them. So it's going to have a gradient of 2 and a y-intercept of 5, so minus 5. Let's work out what this intersection point here is going to be. It's when the y-coordinate is equal to 0, so it's going to be at 5 over 2. Rearranging this, you'll set up a little equation which is 0 equals 2x minus 5. Add the 5 onto the other side, you get 5 equals 2x, and then divide by 2, so you get x equals 5 over 2. So there we are, the intersection point there is 5 over 2. The next thing we now need to do is to draw the modulus of this graph. And when you draw a modulus of any graph, what you're going to be doing is you're going to be taking the bottom half of the graph and reflecting it up to the top, effectively making any negative y-coordinates a positive y-coordinate now. So we've now reflected the bottom half of the graph up onto the top. This minus 5 coordinate will also be reflected up to the point 5. Lovely, so there we are. This is the curve of y equals modulus 2x minus 5. The intersection point is at 5 over 2. The y-axis intersection point is at 5. So moving on to part B, find the values of x that satisfy 2x minus 5 is greater than 7. So what I could do to visualize this in blue is I could draw a graph at y equals 7. And I'm looking for the x coordinates where the modulus graph is bigger than it. So I'm looking for this region here, and I'm looking for this region here. Let's now start to solve this. For this graph here is actually the negative version of 2x minus 5, and we'll have to set this equal to 7 to work out the point at which it equals 7. Why is it the minus bracket 2x minus 5 graph? Well, because we've had to reflect it up to the top, we've had to negate the negative coordinates to make them positive, so we're going to have to negate these old negative coordinates to now make it equal positive 7. So expanding the brackets, 2x plus 5 equals 7. Taking away the 7 onto the other side, adding 2x onto the right hand side, we're going to get minus 2 equals 2x, so minus 1 equals x. So this point here is going to be minus 1. We'll write the final answer out in a second. For this graph over here, this was the original part of the graph, so we won't do any negating of the equation there. It's just 2x minus 5 is equal to 7. So now let's add the 5 onto the other side and divide by 2. We get x equals 6. So this coordinate here is the coordinate 6. So it's going to be the final answer, which is x needs to be a value either less than minus 1 or x is going to be a number that's bigger than 6. So there we are, that's how we answer these sorts of questions here. Then it comes in two parts. One where you solve the equation normally that we did second, and one part where you have to solve for the negated version of what's inside your bracket that's been made that was a negative, and you've had to negate it again to make it into a positive value. So you've had to put a negative sign at the front to make it equal positive 7, because the value that's inside this bracket is going to come out to be a negative value. Let's think about it. If we put minus 1 back in here, 2 times minus 1, that's minus 2. Take away 5, that's minus 7. Negative of minus 7 is the coordinate 7. So you can see how that works when we put the x value back in. So this is the solution here. We want the curve, we want the modulus graph to be bigger than the 7 intersection point. So we're going to have it as less than minus 1 and more than 6. Okay, and moving on to the final question then. Find the values of x which satisfy the modulus of 2x minus 5 is bigger than x minus 5 over 2 write your answers in set notation. Okay, let's move back to red. I prefer red. Let's draw the graph again. So first of all, this was our 2x minus 5 modulus graph. And let's now draw this graph here. It's going to be less steep than the 2x minus 5 graph. This here has a gradient of 2, or minus 2 in this case here, and this graph here has a gradient of 1. So when we draw these graphs, it must be clear that this graph has a steeper gradient than this graph here. So it's going to have an intersection point at minus 5 over 2. Try and get the scaling about right to this 5 over 2 here. So this is minus 5 over 2, and it's going to have a gradient of 1. Well, I think what's going to happen in this case here is that it's going to go up and perfectly intersect this coordinate here. So in fact, so it's just going to be all of this graph is completely on top of this other graph, just apart from this coordinate x equals 5 over 2. So in set notation, x exists in the set of real numbers, but not 5 over 2. Another way of writing this could be something like x equals, so x exists in the set of real numbers, but x is not equal to 5 over 2. Because we want it to be strictly greater than it and never equal to it, otherwise they'd have an equality sign inside that inequality there. So there we are, x exists in, you could put the x inside the squiggly lines as well, doesn't particularly matter too much. So one of these three answers will be absolutely fine as your answer in set notation. So there we are, 6 marks for this question here, question 4. Let's now move on to question 5.